So for today, we're talking about parabolas. All right, and we've dealt with parabolas before, right? But normally it was I gave you the equation and I said, find, what does the graph look like, and find the vertex and all that stuff, right? So chapter 9, its actual name is it's about conical sections. Okay, and what does the word conical mean? What math word does that sound like? Any ideas? 3D object is what I'm thinking of. You put ice cream in it. Right. Okay, so a conical section is things that are curved. Like a cone, it has curves to it, right? So everything that we're going to be dealing with in this chapter are curved graphs. So we've got parabolas, circles, ellipses, and hyperbolas. Okay, and they have a lot of similar things. So I'm going to talk a little bit about the background on it, on what these terms mean, and then we'll get to work with parabolas in particular. Okay, so everybody okay with the red line here being the graph of a parabola, right? It's parabolic. Everybody okay with that? Yes, no, maybe? Yeah. Okay. So what we've got is, everybody remembers the axis of symmetry from last year, right? Where it cuts right down the middle of the graph, and it creates a mirror image on both sides. Okay, the new stuff is anytime you have a curve, you create something called a focus. Okay, what does it mean to focus? Okay, to pay attention to one thing. What about for a camera? Okay, so like if you focus on something in front of you, what happens to the stuff behind you? It blurs out. If you focus to the stuff in the background, what happens to the stuff in the foreground? It blurs out, right? So for us, mathematically speaking, a focus is where you have the distance between this point and the edge of the graph is going to match the distance it takes to go from the graph to what we call the directrix. Okay? And these are used in construction techniques for curved items. Like if you guys see satellite dishes, right? Well, why is the transceiver a certain distance away from the dish? It's at what's called the focus point. Okay, so it's extended as far away from the dish as possible to gather as much information as it can hit, but at the same time, everything that hits the dish can focus in on it. Everybody okay with that? Yes, no, maybe? Right, because you guys know that's how satellites work, right? You have a transmitter, and it hits the dish and bounces up, and then when it receives a message, it hits the dish and bounces back to the transceiver. So your dish is basically reflecting the waves down to a single point. But a single point is called the focus. All right, so if you think about a dish, if this is your dish, right, this is where the transceiver sits. Everybody okay with that? So like a bigger dish, right, the further away the transceiver sits. That's why a bigger dish has more power. It can receive more information. Is because it covers a larger possible area. Okay, so anyway. So we have two new things. We have the focus and we have the directrix. Okay, the directrix has to be equidistant from the graph in relation to the focus. So like what we use as our primary determiner is the vertex. Okay, so everybody okay with the vertex, right? What's the distance up here between the vertex and the focus? How many units between the vertex and the focus? 3, right? 1, 2, 3. How many distance between the vertex and the directrix? 3. So that distance has to be the same. The distance from vertex to directrix has to be the same as the distance from vertex to focus. Everybody okay with that? Yes, no, maybe? So that's what I mean when I talk about a focus, or in plural, it's called foci. Okay? That means that I have a curve, and there's going to be a point where everything I draw, it'll be equidistant from every point on that curve. Is everybody all right with that idea or no? So like the distance from here to here is the same as the distance from here to here as the distance from here to here. Okay? That's what's going on. That's what the focus point really means. So here are your two formulas for parabolas. Okay, so you have one where x is squared, and you have one where y is squared. So if x is squared, your parabola is going to point like this. It's going to point up or down, kind of in the regular version, right? You guys are used to seeing stuff like this, right? So that's when x is squared. Its focus is going to be at the point 0, comma p, because it's going to be on everything we're dealing with, right? There's no k out here, So your graph is not going to be moved left or right. They're only going to be moved up and down. Is everybody okay with that? Yes or no? All right. Your directrix is going to be at the line y equals negative p. So if your axis of symmetry is vertical, your directrix is always perpendicular to it. Okay, so if our axis of symmetry is vertical, then our directrix has to be horizontal. Is everybody all right with that idea? Yes, no? So whatever equation you get for your axis of symmetry, the directrix will always be perpendicular to it. So for us, though, because for these problems, we're guaranteeing that our vertex is going to be on the axis of symmetry and actually on the y-axis. The directrix is going to be at y equals negative p, but the vertical axis of symmetry is always going to be at x equals 0 for these. All right, everybody good with that? Yes, no, maybe? All right, so what you're going to be doing, What? Yes, and you do want it split up. Now, the thing is, when we do a quiz or test, I forgot, I actually give you a formula sheet for this section, all right? So just remind me. So you don't need to worry about putting those on your cheat sheets. Just before we take your quiz or test, remind me to grab them, okay? So over here, y squared, or y is squared, right? So which way is the graph going to point? Instead of pointing up and down, it's going to point what? Left or right, okay? So these are the parabolas that are going to look like this. Right, we traditionally call them square root functions, but it's mathematically the same thing as having y squared, right? Like, how would you get y by itself here? What would you do to get y by itself? Right, you'd square root both sides, right? So you get the positive square root, which is the upper half, and then the negative square root, which is the bottom half. Okay? Everybody all right with that? Yeah? No? Maybe? So make sure you have all of your information written down. All right, so what you're going to be doing is they're going to ask you to graph a parabola. All right? So now instead of finding the vertex and making an XY chart and a domain and range, you're going to be finding the focus, the directrix, and identifying the axis of symmetry, and then graph the function. Everybody okay with that kind of an idea, you think, maybe? All right, so let's take a look at an example. So if I gave you this function, now we have to identify which of those functions that I gave you, which of those formulas fit this, right? So what we do is we look for the square. Which variable do I have squared here? Y. Okay, so if you take a look, do I have any of the formulas have a y squared? Yeah, but is it by itself or is it with stuff? It's by itself. It's isolated, right? So how do I isolate the y squared here? Multiply both sides by 8. Is everybody okay with that? So y squared is equal to 8x. Any questions? Okay. So now this is the equation that I'm going to use to find all of my other information. All right. Now, if you take a look at the formulas that I did have written up just a minute ago, I'll go back. What's the odd variable in here? What's the variable that's new that you're not used to seeing? P. Okay, so P is just some number, right? But if you notice, what do I have for my focus? Which variable? Okay, what about my directrix? And then I have my axis of symmetry, which I just use depending on which format I'm using, right? So P is something that I need. I need to know what P is. So over here, I have y squared is equal to what? 4px, right? So what that means is that when I have an equation written out, anything multiplied with x has to be equal to what? 4p, right? If the formula is y squared equals 4px, then whatever is being multiplied with x down here has to be equal to 4p. Is everybody all right with that idea? Yes, sir? Okay, so 8 is equal to 4p. So now how do I get p by itself? So what's p equal to? Okay. So now I find all my stuff, right? So I've got a focus I need to find. Focus. I need a directrix. And I need my axis of symmetry. Okay, my focus I know is going to be a point, so I'm going to set that up as a point. All right, directrix is going to be a line. Axis of symmetry is a line. So which variable did you say I had squared? y. So over here, that's going to be this bottom piece, right? So all I do is fill in. What are the coordinates of my focus? P0. So what's my p-value over here? So I get 2, 0. There's my focus. Done and done. Everybody okay? Yes, no, maybe? What's the equation for my directrix if I'm using the y squared equals 4px formula? Okay, x equals negative p, which in our case is a negative 2. All right, now if it's y squared, where's my axis of symmetry? Is it a vertical symmetry or is it horizontal? Okay, so what's the equation? Y equals 0. Everybody all right? Yep. And the reason is because for this setup, right, it's a little weird with parabolas. When we do ellipses and hyperbolas, it'll make a lot more sense. But because parabolas only have the one curve, it's a little strange. If you notice, I don't have any k's out here, right? I don't have my traditional x minus h quantity squared plus k form. So what that means is for us, because there is no k, we're always going to have a vertex at 0, 0. Okay? So if I were to make an xy chart here, and I went my usual values, right? Plug in a 0 for x, right? What's 8 times 0? What's the square root of 0? Okay, plug in a 1, right? 8 times 1, square root of 8 is going to be plus or minus, right? Something. Square root of 8 is 4 square roots of 2 square roots of 2, so 2 times 1.414. 14 is 28, so it'll be 28, 28, 0.2828. Everybody okay with that? Yes, no, maybe? Okay. So I could keep doing this, right? I'm not going to. But everybody okay with where that's coming in at? Yeah? Okay. Because I had to square root to get the y by itself. So remember, whenever you square root a number, you always get plus or minus. Okay? So actually, why don't we just keep going? What's 8 times 2? 16. Square root of 16 is 4, but it's going to be plus or minus 4. Because again, we got 2 answers, right? Because we're square rooting a value. Plug in a negative 1. What's 8 times negative 1? Negative 8. What's the square root of negative 8? Doesn't exist. Can you square root a negative? Not unless you're using eyes, right? So what's 8 times negative 2? Negative 16. Can I square root negative 16? No. Everybody all right? Yes, no, maybe? Okay, so what I'm going to do now is I'm going to graph with all my stuff. So this is what your graph should look like out of this section. All right, so first things first. Where was my vertex? Did you guys write down the table or no? Let me go back. Please write down this table right here, table of values. All right, so that way we can graph. So make sure you have this. So that way you can tell me what to do. And make sure that you have this. So this is the type of information we're going to be using. So we're still going to be using our table like normal, right? The regular 5 values. But I'm also going to be using a focus, a directrix, and an axis of symmetry. And you have to label all of them when you graph a parabola. Okay? When you graph parabolic shapes from here on out, I want to see the focus, the directrix, and the axis of symmetry. Everybody all right? Yeah? Okay. So what's my vertex? 0, 0. Okay, when I put in a 1, what did I get? 0.28. Positive, negative, right? When I put in a 2, what did I get? Oof. Okay, can you double check me? Because that doesn't feel right. So plug in a 1, square root of 8. 2 point. Sorry, I'm an idiot. I didn't move my decimal. You got, thanks. Have you guys seen Office Space? Always forget some kind of a mundane detail. $128,000 is not some mundane detail, Michael. That's what happened. I forgot a decimal. I'm sorry. So it's 2.828. All right. That looks a little bit better, right? So 2.8. 2.8. Everybody all right? So these are for my regular parabolic shape, right? So I know that I'm curving up like that, and I'm curving down like that. Everybody good? Yeah? So now I have to put the new stuff, right? So what did you say for my axis of symmetry? Okay, is it x equals 0 or y equals 0? Y equals 0. And we always use a dashed line for axis of symmetry, right? So, axis of symmetry. Done. Everybody okay? Where did you say the directrix was? Okay, what kind? Was it just -2? X equals, so what kind of a line is that? That's going to be a vertical line. So we always use solid lines for the directrix, dashed lines for the axis of symmetry. So I've got my axis of symmetry, right? Axis of symmetry here. And what's this blue line here called? The directrix. Okay, and then what's the only other thing that I have left to do? Focus. And where was the focus? 2, 0. Okay, and then this is your vertex like normal. So when you graph, this is what I want to see. I need to see the axis of symmetry labeled, the focus labeled, the vertex labeled, and your directrix labeled. Okay, axis of symmetries are always dashed lines. Directrix are always solid lines. Okay? So is this hard? It's different. The hard part is finding P. Once you have P, you just plug it in and it tells you exactly what to do. Everybody all right with that? Yeah? And then you're going to use the same 5 values every time you graph. -2, -1, 0, 1, 2. And just plug them in and get the decimal, plot them, put your 3 new things on it, and you're done. Okay? Any major questions on graphing a parabola? Yes, no, maybe? So now, as far as trying to figure out which formula to use, I have 2 of them, right? So what is it that I'm really looking for? I'm looking for the squared, okay? If squared is on x, then I know I'm using this top row of information. If the power of 2 is on y, then I know I'm using the bottom row of information. So that's all I'm actually doing. So before you start, just ask yourself, all right, which piece is squared? That tells you what your graph should look like as far as your function. Isolate the variable, and then do exactly what it says. Everybody all right? Okay, so this is chapter 9. All right, the hard part is analyzing. Taking a look and saying, okay, what did they give me? What do I actually have to do? And then do it. Okay? And this is it. This is 9.2. These 2 formulas, that's it. Or actually these 2 rows of formulas. All right, everybody good? Yeah, maybe? I don't know. All right. So, let me bring up your homework. Please get this written down. Tomorrow you will get to ask questions on it. All right, and again, this chapter isn't super hard. It's just weird, okay? You have to follow exactly what the formula says and be as precise as possible. The biggest issue that students have with this is you try to change the formula because you don't feel like doing all the work, or your brain thinks it sees a pattern that isn't necessarily there, okay? The whole idea behind a formula is that they never change, hence the word form, right? So make sure that you're just doing what the formula says when it says to do it.